Okay, let's start with number 2. Your conclusion always has to directly come from the given. So, if I told you that segment AB was perpendicular to segment BC, I want you to ask yourself, what marking would I be allowed to add to my picture? If I told you those are perpendicular, what would you mark on the picture? You would all go in there and you would put a right angle. So you need to write down that you're putting a right angle. You can't write down that angle 3 is congruent to angle 4. Is that what perpendicular means? It has to come from here. Does perpendicular mean congruent? No. Perpendicular means they intersect at 90 degrees. So my conclusion is that angle 3 and angle 4 are right angles. Or you can put that their measures equal 90. Either way. And then what's my reason why? The why is almost always in the given. Given that they're perpendicular. So my why is, by what the textbooks say, definition of perpendicular lines. By definition, if they're perpendicular, then they form right angles. So look at number 9. Given segment AE bisects segment DB. So you have to be careful. Which segment is bisecting the other? Which segment is getting bisected is what's more important. Which segment is getting bisected? This one's doing the bisecting. This one got cut in half. CD got cut in half. So when you're told that a segment got cut in half, what do you add to the picture? You add tick marks. Now we have to write what those tick marks mean. Other people might not know what that means, so we have to conclude it with mathematical language. Conclusion, segment BC is congruent to segment DC. Your conclusion could not have the letter A or the letter E in it. That was the one doing the bisecting, not the one getting bisected. Okay, and what's the Y? The Y is almost always in the given definition of, be careful, I've had people put angle bisector even though angles weren't involved, definition of segment bisector. 13, given angle 1 is congruent to angle 2. Notice that this one is really only involving one of the triangles. It's not really being used to prove triangles congruent. So what I'm saying is, I give you a triangle, and I give you that, what can you conclude? Now, you have to be careful. You can't immediately conclude isosceles, because does the definition say, an isosceles triangle, a triangle with two angles congruent? No, that's not what the theorem says. So first, or the definition rather. So first, we need to say, oh, we learned that if those angles are congruent, then the sides opposite are congruent. In the next step, we could now say it's isosceles, but isosceles is not the immediate conclusion. The immediate conclusion, let's see, this is A, is that segment AB is congruent to segment AC, and that is the isosceles triangle theorem. Even though we haven't even established it's isosceles yet. But yeah, if it's a triangle and it has two congruent angles, then the sides opposite are congruent. Number 20, given, oh wow, all this stuff is just handed to us. It's like Christmas early. So we just get to go to our picture and we get to mark it. We don't have to have a reason to mark it. It's been given to us. BC is congruent to FD. That's kind of hard to mark because they're overlapping. AD is congruent to ED. I have to use a double tick mark because I've already used that single. And angle B is congruent to angle D. So it's saying, what can you conclude? Well, it's already helping you out. You have to conclude the triangles are congruent, so that's nice. ABC, let's name it in the same order. EDF. And the reason, we have two tick marks and one arc. We have two sides and one angle. So then we ask ourselves, is the angle between the sides? Is it between the tick marks or not between? And in this case, the answer is, yeah, it's between. So we write guilty. Guilty by side angle side.